Hello everyone, welcome to today's class, and this is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics paper 5-1 for October-November 2024 for questions 1 to 4. Question 1, Nicola throws an ordinary fair six-sided dice. The random variable x is the number of throws that she takes to obtain a 6. Now, of course, for a fair six-sided die, we have the sample space is comprising of 1, 2, 3, 4, 5, and 6. And the probability of obtaining each of them is 1 over 6, okay? Now, they say that the random variable x is the number of throws that she takes to obtain a 6. And then here they are telling us that we are finding probability of x less than a. So the number of times the experiment is done is not known, okay? So therefore, this is a geometric distribution. So I can say this is a geometric distribution since n isn't fixed. The outcomes are all independent of each other. When you throw, you can get a 1, you can get a 2, a 3, a 4, like that. So what is our P? Our P is the probability of getting a success is when you get a 6, which is 1 over 6. Okay? 1 over 6. And then Q is 5 over 6. The other numbers which are not 6. So probability of us getting the 6 in less than 8 times, I can draw what we call the tree diagram. So the tree diagram here for the geometric, I can get the success on the first one. If I fail, then I continue. The success is here. Then if you fail, you can continue like that. So less than 8, I will go up to 7. P and Q, these are 1, 2, 3, 4, 5, then 6, and then 7. So that means to get the success in less than 8 times, I can have the first time, on the second time, on the third time, on the fourth time, on the fifth time, on the sixth, and then on the 7th time. So all of those ones. But you realize that it is only this one that I've left out. So instead of disturbing myself by finding P, then plus Q, P plus Q squared, P up to the other one, I just need to say 1, then minus this Q power 7. Okay, 1 minus Q power 7. This is Q power 7. Okay, then I'll have 1 minus. Our Q is 5 over 6, then power 7. So what do we get when we put in the calculator? 1 minus 5 out of 6. Then we power this with a 7. So the answer is 0.721 to 3 significant figures. 0.721. Okay, to 3 significant figures. Part B. Find the probability that Nicola obtains a 6 for the second time in her 8th row. Okay, in her 8th row. So I have 1, 2, 3, 4, 5, 6, 7, 8. So there is a success here. Let me write there a 6. Now here, this person must have gotten a success probably on the first time, on the second throw, or on the third one, or on the fourth one, on the fifth one. So here we are having only one success, and 6 failures. Okay, 6 failures in these 7 throws. So I will treat this one as a binomial. So I will have probability here is going to be equal to, out of the 7 times, only 1 is a success. So what is the probability of getting a success? It is 1 over 6, okay? It is 1 time. And then failures are 6, so 5 over 6, then power 6. And then times, I will multiply by the probability of getting a 6 on the 8th row. So that is 1 over 6. So all of this together, when we put in the calculator, what do we get? So 7 combination 1 is 7, okay? Then times 1 out of 6, I'm going to put it to power 2 because there is the last one and then this one in the binomial. Then times 5 out of 6, then I'll power this with a 6. So altogether, that one is 0.0651. 0.0651 to three significant figures. That is that. Question 2. The random variable x takes the values -2, -1, 0, 2, 3. It is given that probability of x is equal to k into x squared plus 2, where k is a positive constant. Part A. Draw up the probability distribution table for x, giving the probabilities as numerical fractions. Okay, now let's begin. If I'm finding probability of x which is equal to -2, the expression is given here as a function. So I'm just going to substitute there and put -2 here. You square it, then plus 2. -2 squared, that is a 4 plus 2, that is a 6. Then we shall have 6k. Then probability of x is equal to -1. This one is going to be k into -1, again squared, that will be a 1, then plus 2, that one gives us a 3, so we shall have 3k. Then we have probability of x which is equal to 0, that will be k here, then 0 squared, which is a 0, plus 2, that will be a 2, so we get here 2k. And then where x is equal to 2, we shall have k here into 2 squared, which is 4 plus 2, that one gives us 6, so this one will be 6k. And then lastly, we have probability of x is equal to 3. This one is going to be k. Then here, 3 squared is 9 plus 2. And then this one gives us 11. So we shall have 11k here. Now, we know that for every probability distribution, summation of all values of x, okay, probabilities all add up to 1. Okay, so meaning I'll get the 6k, then plus 3k, plus 2k, plus 6k, plus 11k, then I will get to 1. Okay, so this will be 9, then plus 11, that will be 20, then 28. So I'll get that one as 28 of k, which is going to be equal to 1. So meaning k is going to be equal to 1 over 28. So we needed to get this value of k because they asked for numerical fractions. They didn't say put the probabilities in terms of k. You see that? Now we can draw our table. So this is the table here. So we have x values and then their probabilities. Probability of x is equal to x. So the values, we have -2, we have -1, we have 0, we have 2, we have 3. Okay? Then I can put them in a table like that. Then we can put the probabilities. So for the first one, it is going to be 6 out of 28. Just substitute the value of k. Okay, then here we shall have 3 out of 28. The next one will be 2 out of 28. The next one will be 6 out of 28. And then this one is going to be 11 out of 28. As simple as that. Now, next, they want us to find the value of the variance of x. So, I need ex and I need ex squared, okay? Now, to produce smarter work, I'm just going to get the whole of this. Let me just copy this, okay? And then, let me just duplicate it and then I put it just down here. Like that. Then I can add on the columns for x times probability of x is equal to x, because this one will give me the expectation, the ex. And then I will have x squared times p, probability of x is equal to x. Now we can multiply this times that, this times this times that, this times that, and this times that, okay? So doing that, -2 times 6, we shall get -12 over 28. Then here we shall have -3 over 28. Here we shall have 0, then 12 over 28. And then here we shall have 33 over 28. And then square this one, it will be a 4. Then times this, that one will give us 24 out of 28. and then square this one, it will give us a 1 times the probability. That one will give us 3 over 28. Square the 0, it is a 0. Then times the probability, so that it will be that 0, okay? Then 2 squared will be a 4, then times 6, it will also give us 24 over 28. 3 squared will give us 9, times 11, that is 99 over 28. Then here, when I sum up, this one will give me the e of x, and then this one will give me the e of x squared. So let's add up. Of course, this one here is going to cancel with this one, okay? Then after that, we shall have negative 3 plus 33. That one will give us that, okay? So meaning this one is 30 over 28. And then how about this one here? We have 24 plus 24. That is 48. 48 plus 3. That will be 51. So 51 plus 99. That one will give us 150. Okay, so I'll write 150 out of 28. Now, having gotten those sums there, our variance is going to be, so variance is going to be this ex squared, then subtract the ex, then squared. So what do we get as our answer here? 150 out of 28, then subtract. We have 30 out of 28, and then squared. So this one will give us 4.21 to 3 significant figures. 4.21 to 3 significant figures. As simple as that. Number 3 is coming from statistics. The time taken in minutes to walk to school was recorded for 200 pupils at a certain school. These times are summarized in the following table. Now we are given the upper class boundaries and then the cumulative frequency. And those are the ones we are supposed to use to draw the cumulative frequency curve, or what we call the ogive. So meaning the cumulative frequency here, the cumulative frequency curve we are going to draw, make sure that your graph covers at least 3/4 of the graph paper, okay, of the grid. Now, since this one goes to 7, and even these ones are multiples of 5, so I can use 5, 5 on the lower axis here. So you need to put we need to put the axes. So I will draw this one. Get your ruler, you draw it smartly. And also this one here, like that. Put on the arrows to show where they are increasing. And then here you can have 0. Then this will be 10, 20, 30, 40, 50, 60, then 70 here. Now in the middle, that will be a 5, then this is a 15, and this is for the time. The time, t minutes, okay? Then up here, for every 5, 5, since these values are big, 200, and the graph you can see the grid is small, so I can use, for every 5, 5, we have 20. So in other words, here I will have 40, then here this will be 20. Then we can now plot those upper class boundaries. You plot them against the cumulative frequencies we have gotten. Okay, so we have 15 and 18. 15 is here. Here, one small box. You need to get the equivalence of a small box before you start. So one small box here is equivalent to, I have 20, I'm adding 20 every now and then, but divide by 5, this one will be equivalent to 4. And then, of course, here it is 1. Now, 15 and 18. Okay, 15 and 18. So this will be here. This one here is going to be 16. Now, 18 is going to be in the middle. So I'll put it here in the middle and put that circle there. And then next, we can go to, this is 46, 25. 46, and then 25. So 25 is here, 40 is here, 44, this is 48, so 46 has to be in the middle here. That is my next one. Then the next one is 30 and 88. 30 and this is 84, then 88 is exactly here. Then the next one is going to be 40, 140. 40 and then 140 is exactly here. Then the next one is 150 and 176. No, 50 and 176. 50 and 160. Then 64, 68, 72, 76. So it has to be here. Okay. Then the other one is 70 and 200. 70 is here and 200 is here. Now, joining our points, this is what we are going to have. Try your level best to be so smooth as much as you can. Then now this to this, that, and then we can extend this one here to the 0. Okay. Then after that, that is our graph. They are telling us that use your graph to estimate the median and the interquartile range. So median, it is that value that divides the given distribution into two equal parts. So we shall say 200 divided by 2, and that will be the 100th value. Okay. Then we get the lower quartile, which is a quarter of the 200, and this one will give us the 50th value. We are going to read all of this from the graph. And then how about Q3? The upper quartile is 3/4 of the 200, and then this one will give us 150. So 150th value. What do we get? Now, you get your ruler and you draw 100. So let me actually use another color. So 100 is here. Then I make it meet this graph here. And then I can come and read off this value here. So you can see that this one is 30, 33. Okay. So that is 33, the median. And I write it here as 33. Then the next one, 50. Again, get your ruler. And then 50, it is in the middle. It is in the middle of 40 and 60. So like that. And then I'll also come down here and read off that. So this one is going to give me 26. Okay, 26. So my answer here is 26. And then for the upper quartile, I'm going to draw at 150. So 150 is in between 140 and 160. So it is here. Then I go read off from down here. So that one gives us 42. Okay. That is 42. Now, having gotten that as 42, I'll come down here and I write it 42. And you know that interquartile range is the difference between the upper quartile. Okay, IQR is equal to 42, then minus the 26. It is the difference between the upper quartile and the lower quartile. And this one gives me 16. Okay, 16. Now, since we are not all going to draw the same smooth curve here, they are going to give you a range within which your values lie. Okay, like for example, the range they give here for upper quartile, it has to be between 41 to 43. And then for the lower quartile, it has to be between 25 to 27. But see, they want us to calculate an estimate for the mean value of the times taken by the 200 peoples. Now you realize that we were given the cumulative frequencies, not the frequencies. So we need to find the frequencies, then the x values, and then the fx, okay, for the mean. So I can put them clearly here, the time, which is t minutes. The classes are going to be, remember, we are given less than or equal to 15, 15, 25, 30, 40, 50, 70. So when I go back here, I can write that t. We have 25 here. The next one is 30, then 40, then we have 50, and then 70. So for continuity, I'll write the 15 here. Since it is considered here, I won't consider it here. So I write something like that. 25, also the same, then 30, less than, then 40, less than, then 50, less than. And then, of course, now here I can take this one to 0, okay? To 0. Then from there, I can also have, I need to find the frequencies. Then after, the mid values, because this is group T data, and for group T data, we don't know the individual data points. So therefore, we have to, in the estimation, we get the median, okay, or the average. Then we get the upper limit plus the lower limit, then divide by 2. And then after, we find f times x, because mean is going to be summation of fx divided by the summation of f. So you need frequency, and then after, you also need x. Then after getting x, you need to also multiply them, so the summation of fx. You see that? Now, I put this one is in the table like that. Now, the first cumulative frequency is the first frequency. Okay? This one is given as 18. So I'll write here 18. And then the second one. So since cumulative frequencies are got by adding the frequencies, then to get the frequencies, I will subtract. So 46 minus 18, 88 minus 46, this one minus that, like that. Okay? So we are going to have here, the next one is going to be 46 minus 18. 46 minus 18. Actually, this one gives us 28. And then the next one will be 88 minus 46, which gives us 42. Then 140 minus 88. That one gives us 52. And then we have 176 minus 140, which gives us 36. And then the last one was 200, then minus this 176, which is 24. Okay, of course, the summation of frequency here, since these are 200 pupils, so we shall have this one as 200. And then x, you get this plus this, divide by 2. So this one will give us 7.5. 15 plus 25, that is 40, divide by 2, 20. And then 25 plus 30, that is 55, divide by 2, we shall get 27.5. And then we have 30 plus 40, divide by 2, that is 35. And then 40 plus 50, that is 90, divided by 2, that will be 45. And then 50 plus 70, that is 120, divided by 2, that one becomes 60. Now we multiply these ones here. Okay, so 18 times 7.5. 18 times 7.5, we get 135. 135. Then 28 times 2, that is 56. Then I'll add on the 0 here. Then 42 times 27.5. 42 times 27.5. This one gives us 1155. 1155. And then 52 times 35. 52 times 35. That one is 1820. 1820. And then 36 times 45. 36 times 45. That one is 1620. And then 24 times 60. 24 times 60. That is 1440. So what is the summation of fx? 1440 plus 1620 plus 1820 plus 1155 plus 560 plus 35. So this one is 6, 7, 30. 6, 7, 30. So our mean is therefore going to be that 6, 7, 30. Then we divide by the 200. So what do we get? 6, 7, 30 divide by 200. And this one gives us 33.65. So I'll write 33.65. Don't write 33.7 because you are supposed to write your answers to three significant figures. We do so for answers which are not exact. Okay, this one is exact. A terminating decimal is an exact figure, so you leave your answer there. Question 4. Rahul has two bags, X and Y. Bag X contains 4 red marbles and 2 blue marbles. Bag Y contains 3 red marbles and 4 blue marbles. Rahul also has a coin which is biased so that the probability of obtaining a head when it is thrown is a quarter. Rahul throws the coin. If he obtains a head, he chooses at random a marble from bag X. He notes the color and replaces the marble in bag X. He then chooses at random a second marble from the bag. So this is speaking with replacement. That means the probabilities don't change. Okay. Then if he obtains a tail, he chooses at random a marble from bag Y. He notes the color and discards the marble. That is now picking without replacement. He then chooses at random a second marble from the bag. So in here, the totals are reducing by 1 when we are picking without replacement. So in a simple tree diagram, I can have throwing the coin, you get a head or a tail. Probability of getting a head is a quarter, and then this one will be 3/4, okay? Then when this person obtains a head, then chooses a marble from bag X. So bag X, we can either pick a red or blue. So I can have blue from X here. And then what's the probability of getting a red? It is 4 out of the total. So it is 4 out of 6. So I'll write here 4 out of 6. Then that means this one will be 2 out of 6. And then if this person obtains a tail, he chooses a marble from bag Y. Okay? And bag Y has 3 red marbles and 4 blue marbles. So in total, those are 7. So that means you can get a red here or a blue from Y. So the red, they are 3, then out of 7. This one will be then 4 out of 7. Then after, this person discards. That means the total reduces by 1. So for the second picking, okay, actually even here, there is a second picking. Okay, for both of them. So red from X and then blue from X. This one is picking with replacement, so the probabilities remain. Red from X, then blue from X. Probabilities remain all through. So red from Y, blue from Y, red from Y, blue from Y. Now, since we picked a red here, it has now reduced by 1, so the probability of picking again is 2 out of, even the total is reduced, okay? It is now 6, so here we shall have 4 over 6. And then, because we picked a blue one here, then we are now remaining with 3, and the total is 6. Even this one will be 3 out of 6 to make this one a 1, okay? That is what we are having there as our tree diagram. Now, they want us to find the probability that the 2 marbles that Rahul chooses are of the same color. So, for the same color, probability of same color, it can be when this person first throws, but then obtains a head, and then gets red, and then red from X, or throws a head, but then gets blue from X, okay? So blue and then blue. Or we can have this person obtaining a tail and then red, okay? Red from Y and red from Y. Or again a tail, then we can get blue from Y, then blue from Y. Now, we can multiply these probabilities. We have a quarter times 4 over 6 times 4 over 6 Then we have again a quarter times 2 over 6 times 2 over 6. This one here is for this. Okay, head, blue and blue. That one there. Then we add tail is 3 over 4. Then red and red from bag Y. So that will be 3 over 7, then times 2 over 6. And then we have the tail, and then we get blue, which is here. So 4 over 7, and then times 3 over 6. So altogether, what do we have? Now here, simplifying, we shall have this 4 times 6, we are getting 24. 24 times 6, that is 144. So I will have 16 out of 144. The same with this one, it's the same denominator, 144, and 2 times 2 is a 4. Then 4 times 7, that is 28 times 6. 28 times 6, that one gives us 168. So we have 168 here. Then 9 times 2, that one will give us 18. Also, this one is 168. And then we have 9 times 4, which is 36. So we have 16 plus the 4. Then all of them are over 144. Okay, then I can add. I also have another fraction where we have 18, then plus 36, and then down it is 168. So it is 29 over 63. 29 over 63, simplified. Part B, find the probability that the 2 marbles that Rahul chooses are both from bag Y, given that both marbles are blue. Now here we are going to use conditional probability. So I have probability of T, okay? Both are from bag Y. So if all of them are from bag Y, that means when this person rolled when they rolled the coin, then it gave a tail. Because if you can check back here, we only see from bag Y when there is a tail here. You see that? So that means there must be a tail. Okay, then after that we can get blue and then blue. So now we are going to have probability of the tail intersection blue from Y, intersection blue again from Y, okay? Then out of probability of the 2 of them being blue. You see that? Now for tail, we are having, and by the way, maybe let me first continue it. This one here, if they are blue, the probability of obtaining 2 marbles which are blue, you can check here. We also have blue here. It is the total. So the head, blue. Then we also have the tail, then blue. You see that? Okay. Now, we are going to go back here and we say that this is going to be the probability of getting the head, then blue from X and also blue from X. Then you add probability of getting the tail, and then you get blue from bag Y and also blue from bag Y. So we shall get the tail is 3 over 4, probability of obtaining the tail, and then blue from Y. So blue from Y, we can see here 4 over 7, then 3 over 6. 4 over 7, then 3 over 6. I will even put it here. 3 over 4 times 4 over 7, then times 3 over 6. Okay, then how about head, blue? Of course, head is, the probability is 1 over 4. So how about blue and blue from that? So it is here, 2 over 6, 2 over 6, and this is picking. It is picking with replacement. So we shall have 2 over 6 times 2 over 6. So altogether, what do we get? Up here, I have 3 out of 4. then times 4 out of 7, then times 3 out of 6. Okay, down here I'm going to have 1 out of 4. Okay, then times 2 out of 6, then again times 2 out of 6. Then I can cross the bracket, then add. Then this one is going to be 3 times 4, 12 times 3. That would be 36. Then out of 4 times 7 times 6. Okay, simplify that. Then it will give us 54 out of 61, all of it together. 54 out of 61. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next video.